Namaste everyone. Here I am going to explain about the geometrical meaning of zeros of a polynomial. First of all, try to understand about a polynomial. An algebraic expression in which variables involved have non-negative integral powers. It means its degrees will be non-negative integers, such that whole numbers 0, 1, 2, 3, 4, 5, etc. All these will be its degrees. And zeros, a real number k is called a zero of the given polynomial px if pk is equal to 0. Now geometrical meaning. I am going to draw graph of given polynomials to understand about its relation between zeros and x coordinates. Suppose a given polynomial of degree 1 or linear polynomial, that is px is 2x plus 3. It is in its standard form as ax plus b, where a is not equal to 0, a will not be equal to 0, then it is a linear polynomial of degree 1, and it will give us a straight line. Suppose I am going to draw a graph by the given informations, which is like this. Suppose this is x. When we put value of x is here, px is equal to 1, x is 1, then y will be 1, 2 into 1, that is 2 plus 3, that is 5. When we put value of x, that is minus 1, then minus 2 plus 3, that is 1. When we put value of this is 0, 0. When we put its value as that is 0, 2 into 0, that is 0, then we have 3. This is y. Suppose px, that is y-axis, and this is x. Value of x will be given on x-axis. Now I am going to draw a graph. Value of x, that is 1. X, positive x, and then y is 5. This point 1 and 5. Minus 1. X is minus 1 and y is 1. X is minus 1, y is 1. Here. X is minus 1, y is 1. Negative direction. This is negative direction. This is positive direction. This is also positive. This is negative. Minus 1 left, plus 1 top. This point. After that 0. X is 0 and y is 3. X is 0, y is 3. This point. X is 0, y is 3. X is 0, y is 3. When we draw a graph, like this, this graph crosses the x-axis. This graph intersects the x-axis at between minus 1 and minus 2. This place, this point is minus 3 by 2 into and 0. Its coordinate of this intersecting point of this graph and x-axis is minus 3 by 2 and 0. Minus 3 by 2 is x coordinate and 0 is y coordinate. this is only one distinct point of x-axis at which this graph intersects, and graph is of y is equal to 2x plus 3. This y is px, polynomial of x. So this point minus 3 by 2 is 0 of this polynomial. As we observed here, 0 of this polynomial is minus 3 by 2, and this graph intersects x coordinate at minus 3 by 2. This is distinct point. This is relation between zeros of a polynomial and graph and x coordinate. This is a straight line, and this is linear polynomial. Its degree is 1 and root is also 1. Algebraically also we can find its root or 0, that will be same. As we know, its zeros will be obtained by equating it to 0. That is 0 implies that 2x is equal to minus 3, implies that x is equal to minus 3 by 2. Algebraically also we obtained here 0 of this polynomial. This linear polynomial is minus 3 by 2. In this way both are same. Now I am going to draw a graph of a quadratic polynomial. Quadratic polynomial, as we know, a quadratic polynomial will be like this: ax square plus bx plus c. It is its standard form where a is not equal to 0. Its degree is 2, and in polynomial its at most number of zeros will be as its degree. Maximum number of zeros or roots will be equal to its degree. Suppose this is x, this is px or y. I am going to draw a graph with the help of this polynomial. This is this is quadratic polynomial. By taking an example of quadratic polynomial, x square minus 3x minus 4. Suppose a quadratic polynomial that is given in form of ax square plus bx plus c, where a is not equal to 0. Here also I have taken an example that is a quadratic polynomial as x square minus 3x minus 4. When we put here 0, value of x is 0, 0 in this column, then value of y, that is 0 minus, it is also 0 minus 4. Now put value of x axis, that is 0, and then value of y axis, that is minus 4. Minus 4, this point. This is now 1, x 1, then y is minus 6. This point. Y is 1, minus 6. Y, x is 1, y is minus 6. X is 0, y is minus 4, this point and this point. After that, x is 2, y is minus 6, x is 2 and y is minus 6, this place. X is 2, y is minus 6. This point is x is 1, y is minus 6. X is 3, y is minus 4. X is 3 and y is minus 4. X is 3, y is minus 4. X is 3, y is minus 4. X is 4, y is 0. X is 4, y is 0. X is 5, y is 6. X is 5, then y is 6. 5, 6. X is minus 1, y is 0. X is minus 1, then y is 0. Minus 1, 0. X is minus 1, y is 0. X is minus 2, y is 6. X is minus 2, then y is 6. X is minus 2, y is 6. Now we have to draw a graph by given information. This will be drawn like this. From this point, graph will go like this. And this is upward parabola. This is a parabola. This curve is a parabola. It is upward. When a is greater than 0, then we have an upward parabola. When a is less than 0, then we will have a downward parabola. And here, two distinct points, a dash and a. This quadratic polynomial intersects x-axis at two distinct points, a dash and a. And these two distinct points are its roots. Those are coordinate of x. Coordinate of x, that is minus 1 here, and here is 4. Minus 1, this is one root, 4, this is other root of this quadratic polynomial. In this way, we got here this quadratic polynomial has at most two distinct points at which the x-axis is intersected. In this way, there are two zeros of this quadratic polynomial, that is x square minus 3x minus 4, and those zeros are minus 1 and 4. Total number of zeros is its number of degree. Degree is 2, and number of zeros is also 2. Sometimes we get such types of parabolas like this. This is upward, and this is downward, or like this, or like this. We can get like this parabolas. In this way, these parabolas, these curves are not intersecting at any point of this x-axis. So, there are no zeros of such types of parabolas or such types of curves, such types of polynomials. Sometimes parabolas cross like this, sometimes parabolas touch like this, exactly at one point only. In this way, a dash and a coincide here, or curve goes like this, exactly at one point only, at distinct point. In this way, we have only one solution, only one zero of such types of polynomials. There are only one zero, and sometimes we have no zero. Now try to understand about a cubic polynomial. This is a cubic polynomial x cube minus 4x. This is a cubic polynomial. Its value is, when we put value of x, that is 1 minus 4, that is minus 3. value of x is 1. This is 1. Then value of y is minus 3. Here. X is 1, y is minus 3. X is 2, y is 0. X is 2, y is 0. X is 0, y is 0, this point. Origin. X is minus 1, x is minus 1, y is 3. Y is 3. Minus 1 and 3. X is minus 2, y is 0. X is minus 2, y is 0. We have graph will go like this. After that we have to come here. Zero, 3 and 2. This is the graph of a cubic polynomial. Here we observe that this curve intersects x-axis at, this is one point, this is second, and this is third, at 3 distinct points. And these distinct points of x-axis are minus 2, 0, and 2. Here we also observe that minus 2, 0, and 2, at which this curve intersects, or graph of this cubic polynomial intersects the x-axis. This is relation between zeros and x coordinates. Since cubic polynomial intersects x-axis at 3 distinct points, so its zeros are, total number of zeros are obtained. Those are 3. In this way, it is general solution of any polynomial whose degree is n. If a to the power n, then total number of x to the power n polynomial, degree of variable will be n, then total number of zeros will be n. At most, number of zeros will be equal to n. This is general solution of a polynomial. If its degree is n, then total number of zeros will also be n. That's all. Thank you very much for watching.